In this presentation, we're going to look at the exponential distribution. So here's the question. In a large computer company network, there is an average of 40 logons per hour in a network. Okay, so that is immediately suggesting something to do with the Poisson distribution. And it's useful to know that in general that there is a connection between the Poisson distribution and the exponential distribution. But anyway, we'll continue. Suppose that the average amount of time between logons is an exponential random variable. So in this case, we're explicitly told that, and that is helpful. So we have four questions here. What is the average amount of time between logons? What is the probability that there will be no logons for at least 2.4 minutes? What is the probability that the next logon will be within 1.5 minutes of the last logon? And what proportion of logons occur between 1 minute and 2.4 minutes? So the solution to part A is what is the average amount of time between logons. So if there are 40 logons in 60 minutes, it's reasonable to think that someone logs on every 1.5 minutes. And indeed, that is our exponential mean, 1.5 minutes. Now, so the question that extends on further to that is what is the rate parameter? And the rate parameter is 1 over mu. Okay? So where x is time between logons, now really you should actually put out more of a sentence than I'm about to do. My pen is slipping here. So time between logons. Okay, I took a brief pause there just to fix my pen. So essentially this is what I was getting at. Just when you're actually writing out a question like this, I find it very helpful to make a quick statement like that at the top of your exam question answer that just actually states exactly what you're doing. Explain what x is and just specify x as a random variable. So here, just following on from what I have above, x is an exponential random variable defined with the rate parameter lambda equals 0.666. Perfect. So we'll move on. So solution to part B, what is the probability that there'll be no logons for at least 2.4 minutes? So there's multiple ways of stating or specifying the answers or the formulae. So this is actually sort of a slight variation of something I usually have in the formula. So this is the exponential of minus k divided by mu. Now equally you could write that as the exponential of minus k times lambda, but I think actually just for the sake of simplicity we'll just use minus k over mu, because we were actually asked what mu was in the previous question. So using the formula sheet, probably a probability of x greater than 2.4 is the exponential of 2.4 divided by 1.5. And there we go again with the pen, 1.5. And that gives us an exponential of minus 1.6. And the answer, therefore, is going to be 0.2018. Okay, so that's the answer to the first one there. With a logon time of between logons for 2.4 minutes, that is 20% approximately. Now here what I'm going to do actually is just to throw in some R code down here. Okay, so the command is the cumulative distribution command here is pexp. Okay, PEXP. Okay, and the value that we're interested in is 2.4 meters. And additionally, what we have to do is specify the rate parameter. And here I just specify the rate parameter as 2 over 3. So this part here is required. Okay, I can write it in as 2 over 3, or it's just to be for full correct use. So 0.666 is fine. Okay, now what this command does, this is the cumulative distribution function. So this is asking for the probability of less than 2.4 meters. Okay, so if I want to get the complement of that, what I could do there is actually specify lower equals false. This gives us the probability of x greater than or equal to k, which is the question that we're being asked essentially. Okay, so that additional command is lower equals false. That means actually we want the probability of x being greater than some value k. Okay, now part C. What is the probability that the next logon will be within 1 minute of the last? Probability of x less than or equal to 1. So from the formula sheet, that is equal to minus k divided by mu. 1 minus e to the minus k divided by mu. In this case, that is minus 1 divided by 1.5. So the exponential of 1 divided by 1.5, the exponential of 1 minus the exponential of minus 0.666. Okay, so that would work out to be 1 minus 0.5135, which is 48.65%. And using the OR code that I just described previously, and my pen keeps slipping, I just unpause it there for a second. So that's the probability of x less than or equal to k. Here k is equal to 1, and that is the code there that you would use to do it. In this case, it's fairly straightforward. Okay, it does not require the additional argument there, so that's fairly straightforward in this case. So moving on. So what proportion of logons occur between 1 minute and 2.5 minutes of the last logon? So I'm going to break this up and consider it as an interval. What we're asked for essentially is the probability of being inside an interval. Okay, the x is inside an interval of 1 minute and 2.4 minutes, where 1 is the lower bound and 2.4 is the upper bound. Now, just as a quick remark, how do I know that? The answer is going to work out to be about 31%. Now, how do I know that it's inside that interval? So what I'm going to consider is what is too low for that interval. So this is collectively what's outside that interval. Okay, it's a very simple approach to tackling this problem. So too low for this interval is 48.65%, 0.4865, and too high for this interval is 0.2018, which are the answers to the previous questions there. Now, if I add them together, I get approximately 68.8%, okay? And the complement of that is what I'm looking for, okay? And that works out to be 31%, 0.3117, okay? So what I have here is outside the interval, which is the combination of being too high and too low, and essentially what I want is the complement of that. Okay, that's great. We'll leave that there.